Okay, so this is Tuesday, 22nd of April, and our new topics today are surds and quadratic simultaneous equations. So firstly, when I'm simplifying a surd, what I use is a product of primes tree. So I would do 20, and then that's 4 times 5, 2 times 2. And I have 20 equals 2 times 2 times 5. But because this is a surd, I put my roots over it and I look for my pairs. Now, root 2 times root 2 becomes 2. And then the root 5 on the end, I just squish them together. So that'll be 2 root 5. Now this one, I'm just going to look at the root 45 using the same method. So 45, 9 and 5, 3 and 3. So 45 is 3 times 3 times 5. Root, 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 root. I've got a pair here. So that's going to be 3 root 5. But we need to be careful because it was 3 times root 45. So plus 3 times 3 root 5, which will give me 2 root 5 plus 9 root 5, which will be 11 root 5. Okay, this one. So we can do it a couple of ways. We can simplify it first, or we can multiply first. Doesn't really matter. Probably easier to simplify first, otherwise we're going to have a big surd to break down at the end. So if I've got 12, that's 4 times 3, 2 times 2. So 12 is 2 times 2 times 3. And this is good revision for your product of prime factors as well. They're going to multiply to give me 2, and then I've just got a root 3 afterwards. So that is 2 root 3 times. And then I've got 18. 2 times 9, 3 times 3. So 18 is 2 times 3 times 3. Put the roots on. Pair, we'll just make 3. And then obviously that's a lot nicer to write like that, 3 root 2. Okay, so then if I'm multiplying surds, what I want to do is I want to look at my numbers in front, the 2 and the 3. They're going to multiply to give me 6. And then root 3 times root 2 will be root 6. So when you have surds that are multiplying that are different, then you literally just times them together. But as before, if we have surds that are multiplying that are the same, then it just becomes that number. So root 2 times root 2 would just be 2. Okay, next one, rationalise the denominator. Okay, so if I've got this fraction and I need to rationalise this denominator, what I'm going to do is I'm going to use dots, difference of 2 squares, and I'm going to multiply it by the same thing, but with a different sign. And to keep it equivalent, I need to times my top by that as well. That will probably get you 1 mark in an exam just for writing that down. Then I like to set it out nicely. So my numerator is going to be 4 root 5 plus, let's just say 2 there, sorry, root 2, which will just be 4 root 5 plus 4 root 2. Okay, the denominator then, I've got this double bracket, which is why I'm writing it out nicely so my examiner can mark it well. So when I expand a double bracket, I split the first bracket up and then I write the second bracket twice. Okay, root 5 times root 5 is 5. Root 5 times root 2 will be plus root 10. Minus root 2 times root 5 will be minus root 10. And then minus root 2 times positive root 2 will be minus 2. And that's what I wanted to happen. I wanted those surds to cancel. So I'm just left with 3 as my denominator. So my final answer will be this numerator over 3. And that is in this form, a root 5 plus b root 2. If I were to just write it as 4 over 3 root 5 plus 4 over 3 root 2, that's fine. Rational just means can be written as a fraction. And rationalise means I wanted to remove any surds from my denominator. Next topic then, quadratic simultaneous equations. Little typo there, sorry. Solve the simultaneous equations. So, I know it's quadratic because this has got squares in it. So that is my quadratic and this is my linear. And you'll always get one of each. So the first thing I have to do is remember that I'm putting the linear into the quadratic, which means that my linear has to have x or y as the subject. Now the easiest thing to do with this linear, because it's 2x plus y equals 3, is to make y the subject by just subtracting 2x from each side. I don't know why it keeps going blurry, I'm sorry. So now y is the subject. And when y is the subject, we can take this quadratic and wherever I see a y, I can substitute that in. So x squared plus y squared equals 20. And because y equals this is the mistake most people make, that is what I'm swapping for y here. So x squared plus bracket 3 minus 2x squared equals 20. Now I'm going to expand this bracket over here because I don't want to confuse myself. So I'm going to split my first bracket up, write my second bracket twice. 9 minus 6x minus 6x plus 4x squared. I prefer writing my x squared at the start, so I'm going to write 4x squared minus 12x plus 9. And that is the same as that. So I've got my x squared from before, but then I've got that as well, which I've now expanded, plus 4x squared minus 12x plus 9 equals 20. 5x squared minus 12x plus 9. And when I solve a quadratic, I want it to be equal to 0. So I'm going to have to take away 20 from both sides. And then think about how I'm going to solve that. I can see that's not going to factorise because that would give me minus 55, which has only got 5 and 11, so it's not going to make that 12. So I will use the quadratic formula. A equals 5, B equals minus 12, C equals minus 11. X equals, so it's minus B, so that's going to be 12, plus or minus the square root of B squared minus 4 times A times C over 2A. When I type it into my calculator, I'm going to have to do it twice, once with a plus, once with a minus. 12 plus root. So 3.1, that's fine, we'll leave it as that. Or if I go back, change it to a minus, minus 0.7. Okay, now they're my x values. When I've got my x values, I actually need to now find out my y values. So I've got these two options, 3.1 and minus 0.7. When x is 3.1, I can substitute that now into my rearranged linear. So y equals 3 minus 2 times 3.1. Which is minus 3.2. And then when x is minus 0.7, if I substitute that into my linear, I get y equals 4.4. So my two solutions are x is 3.1 and y is minus 3.2, or x is minus 0.7 and y equals 4.4. And just a reminder what that would look like on a graph. Let's say, for example, this has been a graphical question instead. That top there is a circle. Okay, that's actually the equation of a circle with a radius of root 20. That then is a line, and it's a line going through 3 minus 2, let's say, roughly like this. What these two solutions tell me is that at the point x is 3.1 and y is minus 3.2, they cross, they touch each other. This one, they cross here. And that kind of makes sense from my diagram. So if the question instead of said just find the solutions from the graph, you would just read off those two coordinates, which would be what we had just worked out as our solution. It's graphical simultaneous equations.